Okay, so circle geometry unit day 3. Okay, technically this is day 4 in the sense that we extended the last unit just a couple days, but that should be okay. So this time we're going to be talking about intersecting chords and angles. Okay, so intersecting chords and angles. So each of these has its own particular set of properties. Okay, so let's talk about the first one. So first one, the angle formed by intersecting chords is given by 1/2 the sum of the measures of the intercepted arcs. So what that is saying, it's saying that this angle right here, or in case this angle right here as well, because these are example of vertical angles, okay? Let's just stick with one. So angle E, this one right here, is equal to 1/2 this measure plus this measure. Okay, so let me repeat that again. What I'm saying here is that, we'll say in this case, AED is equal to this piece plus this piece divided by 2. So it's basically 1/2 of the sum of the measures of the intercepted arcs. Okay, in this case our intercepted arcs are AD and CB. Okay, and by also intersecting, you're saying, well, why not the other two? Okay, well, in this case, right, we're just talking about this particular angle here. All right, rule still applies if we were talking about this particular angle or this particular angle. Okay, it would be this piece plus this piece divided by 2, or 1/2 the sum of those two arc measures. Okay, so let's jump right into an example here just so I can stop talking. So what angle? Well, let's read it. It says example 1. So, given circle O shown below with chords A, B, and CD intersecting at E, what angle is congruent to AED? So it wants to know what angle is congruent to this angle right here. Okay, and hopefully you recognize that this is an example of some vertical angles. Okay, so this angle should be congruent to angle CEB because they are vertical angles. Okay. Letter B says, what two arcs do AED and your answer to letter A intercept? So I'm going to show that in bright green. It's going to be these two right here. Okay. We're looking at the arc located directly across from those particular angles. Okay, so AED, we're talking about the one directly across here. Okay. These two sides pertain to the other two angles. Okay. All right, so it says highlight them, and we did. So it says if the measure of the smaller of the two angles in B is 58, okay, so clearly this one would have to be the smaller one, okay, just going by the size, and the measure of the larger one, 76 degrees, find the measure of AED. So using our property, we would say 58 plus 76 is equal to 134 degrees. And so the measure of angle AED is equal to 1/2 the sum of those two lengths. In this case, is 67 degrees. Okay? Mark that in there. So this is 67, and this is 67. Okay, so letter D says if the measure of arc AC, let's talk about the arc. I'll highlight that and go orange. Okay. So the measure of arc AC is 61 degrees. Then use the theorem above to determine the measure of BD. Now, essentially we wouldn't have to do that, okay, because we would just notice that, okay, we have a circle, and we could just add all these up, subtract it from 360, and find this length right here, okay? But we're going to do it the long way, so we're going to start with our property, starting with this piece right here. Now, okay, so if this is 67, this angle measure right here, okay, what does this have to equal then? And how can I find that? Well, if you recognize that this angle here and this angle here form a linear pair, then you would know that in order to find this angle, you would have to subtract 180 by 67 and get 113. So if that is 113, that means this one right here is also 113 degrees. Okay? And we're still trying to find the measure of this arc right there. Okay? Still trying to find that measure. Let's put what we know together. So we know that 113 is equal to 1/2 61 plus some arc that we don't know. So we're just going to put x degrees. Okay? So in order to solve this, I'm going to multiply both sides by 2. Okay, our 2's are going to cancel on this side. Okay, and you get 226 is equal to 61 plus x. Subtract 61. And you get x is equal to 165. This is check your work. So I'm going to go 58 plus 61 plus 76 plus 165 equals 360 degrees, which is the circumference, which is the angle, which is the degrees of a circle. It's 360 degrees around. Okay. So it says, just a moment. Okay, so here we are. In diagram 2, we would like to prove this property right here. So, let's talk about these two angles right here. So it says, why can we state that the measure of GHE is equal to the measure of angle D plus the measure of angle G. Okay? So let's think about that. What property allows us to say that this angle plus this angle is equal to that angle? Starts with an E. Exterior angle theorem. Okay? And so using what we know about inscribed angles, state an inequality for each. Okay? So we're talking about this one right here. We know that inscribed angle is 1/2 the measure of that arc. So we'd say 1/2 the arc of GE. And then letter G, angle G, I'm sorry, is equal to 1/2 the measure DF. Okay. So using the inequality in A along with the results from B, prove the desired relationship. So I'm going to say the measure of GHE is equal to the measure of D plus the measure of G. And then using substitution, I'm going to say that 1/2 the arc of GE plus 1/2 the arc of DF. Substitute a 1/2 out, or not, sorry, substitute factor out a 1/2. And we are left with what it is we were trying to show. Okay. Take a minute to let that soak in. Okay, exercise 3. I'll let you guys try this one on your own for a second. Go ahead and give that a shot. Okay, so I'm going to do the first one with you guys, and I think the other 3 you guys should be very well capable of, right? So this one, we know this is 90 degrees, okay? And we know that that angle is formed, not formed, but its measure can be found by adding these 2 segments up. So in this case, we don't know what the arc of AC is. We do know what the arc, the arc of DB is. In this case, it's 126. Whoa. Okay, so we are going to go 90 degrees. I'm going to keep it 90 degrees. Is equal to 1/2 126 plus x. Okay, so multiply both sides by 2. And by doing so, your 2's cancel. And you're left with 126 plus x minus 126. X is equal to 54. Okay, so the arc AC is 54. Okay, and so the rest is for homework, you guys. Try this, this, and this one. Okay. Oh, we still got more down here. My bad. So try those 4 or those 3. Let's get to this last part. I'm sorry. One more problem here. 2 more. One an example. So, if 2 chords intersect within a circle, then the product of the partitioned segments of one chord equals the product of the partitioned segments of the other chord. Okay, this is important. Okay, so what this is saying is that this piece times this piece is the same as this piece times this piece. And that's all it is. Okay? Okay, so anyway, here's what you need to know. So AE is 6, BE is 4, DE is 3. What is the length of this one right here? Okay, so what it's saying is AE times BE is equal to DE times CE, okay? Whatever those lengths are. So in this case, it's 6 times 4. I'm just going to put an X in there for CE. And so DE is 3 times X. So you're getting 24 equals 3X. Divided by 3. X is equal to an 8. All right? So this length is an 8. So the fact we partition segments have products that are equal is remarkable and a direct consequence of similarity. We'll explore that similarity in the next exercise. Okay, so given the same diagram with a few extra segments drawn in, answer the following below. So give an argument for why ACE and DBE are similar triangles. Okay, so when I say similar triangles, which we haven't really discussed yet, we're looking for, okay, not so much the same size, but the same shape, just smaller. Okay, and one key aspect is that we're looking at, okay, it's the same triangle, just either larger or smaller, okay? So what's changing is the size, but what's not really changing are these angle measures, okay? So that's what makes them similar triangles, okay? They wouldn't be similar if they didn't have all three of the same angle measures. Okay, so that's what I mean by similar triangle. It just means, whoops, actually I'll leave that up there. It just means that it's either larger or smaller, but it still carries the same angle measures. Okay, so give an argument for why ACE and DBE are similar triangles. So first I want to look at these two angles right here. Okay, and so I'm going to say angle AEC is congruent to angle DEB because of vertical angles. Okay? So my goal here is to try to show that all three of the angles, both of these triangles, are the same, okay? Therefore making them similar triangles. Now, I want to talk about these two, okay? So, I'm going to take note and look at this particular arc, CB. Okay? What I'm going to show you is that we got this angle intersecting that arc, and we also have this angle intersecting that arc. So, what do we know about these two angle measures? These two angle measures are congruent because they intersect the same arc. Okay? And if you haven't noticed already, then we can also say the same thing, okay, about this particular arc AD. As you notice, okay, AC intersects that arc, or ACD intersects that arc, I'm sorry, and DVA intersect that arc. Okay, so therefore, all three triangles are the same. They have three three angles, I'm sorry, the measure of three of their angles for each triangle are the same, so therefore they are similar triangles. Okay? And it says using the fact that ACE and or triangle ACE and triangle DBE are similar. That's what this means right here. It means these two triangles are similar, not congruent. Okay? They just look alike. They aren't the same. Write a proportion involving the partition segments and rearrange it into product form. Okay? I'm just going to say skip that part right here and do these last two for homework. Okay? And that concludes this lesson right here, you guys.